Alright, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. Oh, I forgot to put my series thing at the top there. I'll do that while I'm talking. So we are looking at for each of the following sequences whose nth terms are indicated, state whether the sequence is bounded and whether it is eventually monotone, increasing, or decreasing. And it sounds a little bit like my voice does today, so it's all good. So that galaxy series represents that we've done 30. We've done a set of 30 in the month of, not May, April. That's what it was. And now we're on a new set of 30 in a new month. I skipped May because May had 31 days, so I'm doing 30 of them each month that has 30. That way it's easy to keep track of the math. Ironically enough, I try to make math easier for myself, not harder usually. So let's look at what happens with these n values. We're looking at n, and we're looking at a sub n, which is this sequence here. And if it doesn't say where it starts, then it starts at 1. So that's a sub 1, which is tan of 1. And if they don't say whether we're in degrees or radians, then we assume radians. So that's tan 1, tan 2, and so on and so on. There's something on the screen? I don't know. So let's go, we'll go like skip a few. Tan 10, 100. Oh, almost put theta. Tan 100. And these are radians, right? And then is it doing anything when we go to infinity? Like what is that? To see if there's a limit. So what we could do is we could just graph it, right? And if we graph it, or if you know what the tangent graph looks like, you just have it memorized, then you might already know the answer to whether it has an infinite limit or not. Because if you know the graph, then you know whether it ends or not at a certain place. But let's just go ahead and get a little sketch. Here's the y-axis. Put the x-axis right about here. And we'll have all these spaces just going by ones. So I think I'm going to do this. And we'll zoom in a little bit on this graph here. So the tangent of, let's say, pi fourths. We'll go by pi fourths. Tangent of pi fourths is 1. And the tangent of pi halves is actually undefined. Because tangent is the sine over the cosine. The sine of pi halves is 1, but the cosine of pi halves is 0, so it's 1 divided by 0. Tangent of 0 is 0, because again, it's the sine of 0 over the cosine of 0. Sine of 0 is 0, cosine of 0 is 1, 0 over 1 is 0. Over here we have negative pi fourths, which is negative 1, and then negative pi halves, which is also undefined. So we have some of our undefined values here. This is going to be what's called one period of tangent, and it looks kind of like a cubic function. If you already know what the tangent function looks like, you're welcome to skip this part, by the way. I won't be offended. But here's what the tangent function looks like. So it just keeps doing that over and over and over again. So it does not have an infinite limit. The closer it gets to pi halves, it will never be exactly pi halves. So there's not going to be any undefined values. And the reason why it's never going to be pi halves is because pi halves is an irrational number. If you're counting by ones, you'll never reach an irrational number of any kind. So we'll never reach any pi halves plus pi k multiple. That would be all of the vertical asymptotes that tangent has. We'll never reach any of those because we're counting by ones. And in the same way, this next x-intercept would be at pi. So we're not going to have any 0 values either, because it would only be at pi multiples that we would have values of 0. So we're not going to have any 0 values either. Some of these very, very specific places, we don't have those exact values because we're counting by ones. So there's certain values that we just won't reach. But all other values we should be able to get to. So with that in mind, let's see. Zoom it out, zoom it out, zoom it out. There we go. I think that's good. Okay. Still have a few more of these actually. We've got 7 to go. There's another one. So that's our graph. It's not bounded. There's no number that it can't theoretically reach because it could get really, really close to pi halves or a multiple of a pi multiple of pi halves. It could because you're counting by ones, so there's going to eventually be a number that's really, really, really close to a multiple of one of our asymptotes. So it'll be really, really close to either infinity or negative infinity, depending on whether it's like a little bit less or a little bit more. So it can be pretty much anything from negative infinity to infinity, minus some of those specific values that we talked about. But then, as far as whether it's monotone, increasing or decreasing, well, some values are going to be like between 0 and pi halves, and then other values might be between pi halves and pi, and then other values will be between pi and 3 pi halves, and so on and so on. So then that would mean that we could have values that are going to go up or go down depending on which multiple we're looking at. Let me go ahead and type this in, and we'll look at some of these multiples. And Desmos will default to radians anyways, so that it should be pretty easy to plug this in. Tangent of 1, let's say. So that's going to be 1.56. 1.56. And these are all estimates. I'm rounding to 2 decimal places. F of 2 is negative 2.19. So we went down. All right. What about 3? Oh, what about 3? There we go. Negative 0.14. Now we went back up. So we went down, and then we went back up. So already we're showing that we're doing a little bit of both, which means we're not monotone, which means we're not monotone increasing, and we're not monotone decreasing. We're also not monotone stagnant, if you were wondering, but 0.65, and then 100, just for kicks and giggles, negative 0.59. Yeah, so as it goes to infinity, we don't know because it's never leveling off anywhere. There's no limit to the sequence. When we say does the sequence converge or diverge, we're saying does the limit as the sequence goes to infinity equal a number or not, and it doesn't, so it would diverge. So that's pretty much it. It is not bounded, nor monotone. And you can talk to your teacher about specific ways to answer the questions. If they like to be really picky, then use the language that they would use, but you're going to say something to that effect. Not bounded, nor monotone. It's just nothing. So hopefully that's helpful. Check out the 5 math mistakes everyone makes and how to avoid them. It's on my website, Myers Mathematics, which the link is down in the description below for that. I'll catch you guys in the next video. Blessings, y'all.